Right. Good afternoon. Shall I say good evening already? Well, no, not yet. Although the last session of today and the last session of these two highly loaded, high-load topic days, right? So the last session for today is about a Miro canvas content migration from Postgres to in-memory database and S3. And I'm happy to invite here on stage Vladimir Bukhonov from Miro. So please welcome him, and the stage is yours.
Thank you. Sound check. Looks everything is work fine. So, hi everyone. Всем привет. Baravzes. My name is Vladimir Bukhonov, and I'm working at Miro as engineer and manager. And today I will tell you about how we in Miro migrated Canvas content from Postgres to in-memory storage plus S3 as long-term storage. So let's move to our agenda. First, I will tell you about what is it Miro, about main entities inside Miro, what is it board server, how our widget storage was evaluated, what is it in-memory storage, some implementation details, the third-party databases that we compared, and benchmark results what we have. Also, I will tell you about the problems we faced and the migration process itself. So let's begin. First, what about Miro? What is it? So Miro is online whiteboard collaborative platform for team collaboration. The platforms enables teams to lead engaging workshops and meetings, design products, brainstorm ideas, and a lot of more stuff. Miro serves 45 million of users, and we have currently more than 70 hundreds of employees in 12 hubs all over the world. Let's move to the Canvas entities. So in Miro we have several main entities. First of all, it's board that you can see in the big rectangle. The board allows our customers to manipulate all the content that you can create on the board and all the stuff that you need. The background of board is a canvas, and on this canvas you can create widgets, and with help of these widgets you can create any content that you need. Let's talk about our main application entities. So we have two of them. First of all, it's a web application that you can see right now. It also works with help of Miro. So our clients, web applications, communicate with the board server is our backend with help of WebSockets. And board servers process all the commands from clients and also produce some events to the clients too. All the commands sequentially operates with help of our board servers and stores previously in the Postgres. But right now, let's move about the history. So long time ago, all our the data was stored in the Redis. But we faced with we grow very fast, and we faced with different problems, especially with the data inconsistency, and we decided to move to the Postgres. But we still continue to grow, and we face with the same problem again. So we decided to migrate from Postgres to the in-memory storage. But why in-memory storage and why not Postgres? So first, let's speak about Postgres. So the widgets data basically is a JSON data. We have again numbers of Postgres shards. All Canvas entities are effects on the business logic entities. We faced with a lot of performance issues and very huge costs on the structure. Let's speak now why we chose in-memory instead of all different kind of databases. First of all, as I said, widgets data is stored in the JSON. We store one in-memory storage instance per board, and Canvas entities are isolated and will not affect business logic entities anymore. And as Miro is a real-time collaboration application, we need to perform as best as we can, and that's why in-memory storage is the best solution for us. Now let's speak about how everything is working inside. So when you open the board, the data is loaded from S3 to the instance of in-memory storage. It's a specific instance per board. And all the data that comes from the client are validated by the canvas logic and operates in memory storage. After all the data is snapshotted and saved in S3 as long-term storage. So this is evening, every one of you are tired. Let's have some brain exercise and think about this question. For example, we have a lot of widgets on the board, A, B, C, and we need to update one of these widgets. What do you think? What is the best data structure to apply this operation in terms of speed and performance? Anyone? More? Yeah, hash table or hash map, yeah, you're right. So the best data structure here is hash map. And another question. We have several stickies on the board, and on the Miro, all stickies are ordered. For example, C overlay B, B overlay A. And we need to make a B at the top. What is the best structure for this operation? More ideas? Yeah, you're right, linked list. So under the hood, in fact, in-memory storage consists of several hash maps, linked lists, and transactions works with help of logs. We read only committed, and if you need to write, we are copy and write. Also, of course, there are a lot of different databases that you can use with in-memory. So we compared all of these databases. We implemented proof of competence for all of these kind of databases, but the benchmarks show us that our implementation is the fastest one. So the average operations time for creation widget is 100 microseconds, update is 50 microseconds, and reordering operation is also 100 microseconds. We used GMHA for these kind of benchmarks. So we implemented the in-memory storage as library, but what to do next? Of course, next thing is you need to inject your library in the product. And here we faced a lot of problems. So first thing, even if your library is covered with tests, with all kind of tests, with 100%, you can't be sure that it works the same way as your existing database. That's why we created some kind of proxy storage with a comparator inside. When you're starting collaborating, as I already said, the data is loaded to the in-memory storage, and all operations are applying to this one. But we're also applying them to the Postgres. And at the end of the collaboration session, when everyone leaves, we compare the states of two databases. At this step, we're faced with a lot of differences. It takes us much time to find the root cause, where are the differences. Mostly it was in the specific logic of the Postgres and behavior, how it's saved, and some inconsistency in Postgres and in logic issues. So another problem that we faced, it's Juke records. In the Miro, we are using Juke to communicate with Postgres, and there was near 50 hundreds of usages of widget records. Also, there was joins and foreign keys. And the main lesson that we learned is please use abstraction instead of after-generated entities, because we spent a lot of time to replace them. Another big issue that we faced is that basically our application is a big monolith application, and we have several roles that use the same code base, and this proceeds to the same usage of Postgres. So, for example, API can directly access to the widgets data inside Postgres, maybe override operations, something like this. But in new reality, only board server can manipulate the widgets data, because in-memory storage is on the board server. And that's why we need to refactor all access direct access to the Postgres from direct access to gRPC. And instead, board server becomes a gRPC server, and all other applications types becomes gRPC clients. The next main thing is schema versioning, also known as a migration. As you know, the data construction can be changed during the time, and the different data structure can be stored in this long-term storage S3, and we need to be able to process them all. That's why we implemented such named as transformer that can transform the data from the new data structure to the old one and the old one to the new one. Okay, so we reached the state when everything is implemented. You injected your library to the application, everything works fine, no differences between databases, but we also need to migrate the data itself. We have 28 terabytes of widgets data, and with nature of our board servers, it was pretty easy for us to migrate the data. When you open the board, the data, as I already said, is loaded to the in-memory storage, and the collaboration end, the data is saved to S3. So in fact, we simulate the same thing. So we opened all the boards, closed them, and that's it. So we had a lot of board servers, and we handled to migrate all the data during only 3 days. So, and the last step is to process getting rid of Postgres. All this previous time, we write simultaneously in the Postgres and to the in-memory because we compare the data. And at this point of time, when we now write to the Postgres anymore, this is some kind of point of no return because you can't roll back to the Postgres data. And to cover this case, we implemented different recovery strategies inside the S3 itself and inside the library that communicates with S3. So after we get rid of the widgets data, it takes 93% of Postgres space. Slow queries reduced by 99%, cost reduced by 80%. That includes the cost to the new S3 instances, and the amount of shards, Postgres shards, reduced by 98%, and that allows us to refactor our resharding mechanism to more simple way, because previously it was very complicated. That's all from my side. Thank you for listening. Please ask your questions if you have.
Right, a round of applause. And yes, now it's questions time. So anyone over there, right? So gentleman in the middle was first, then that's you in the queue.
Hello. Thanks for a great talk. I have a question about PG shrink. I guess it's a Postgres extension.
No, it's just getting rid of the data of the Postgres.
It's just a utility.
Yeah.
Does it work in real time? You shouldn't stop your database and so on?
Yeah, it was real time without any degradation because we just remove data step by step, wave by wave, organization.
Have you looked at PG repack?
Unfortunately, I don't know answer on this question, but I guess yes.
Yes, it's a utility that helps to reduce storage size for Postgres in real time without stopping your database too.
Cool. Thank you. Question?
Right, gentleman here at the second row, please.
Yeah, hi, thank you. So my question is, why did you choose S3 as a long-term storage? Like, did you think about MongoDB or something like this? Maybe S3 is better to scale or something. I don't know, like.
Yeah, I got your question. Thank you. So first of all, we are already using all AWS infrastructure, and that's why S3 was the simplest reason. But we are not only using S3. Upfront the S3, we are using our own proxy that also provides caching for us. And if there is some kind of issues with the S3, it's sometimes happening, network issues, etc., we are saving to other databases. The same as S3.
All right, over there, please.
Hello, thank you for the talk. I had a question. Before you saved all the widgets, as I understand correctly, into the Postgres, all these JSON files, right? And now you moved them to S3. If I understand correctly, you could have had some sort of analytics on top of Postgres, like how many widgets I used, maybe what widgets I used, maybe build some statistics. And I suspect you kind of lose such information when you move all your data to S3, and you can't build any of this kind of analytics. Do you have any analytics on that point, or do you have any other solution that handles that?
Great question. So, in fact, we didn't use the analytics request based on the data inside Postgres, because we sent events to the Kafka about all the changes for the widgets, and we have a specific environment where I collect all these changes and make analysis on this environment.
Okay, you said that you load from Postgres in your memory storage, and after that load to S3. But how you provide in memory storage? How to say it in English?
Right. So
Maybe reliability.
okay.
Reliability in memory storage. How do you provide it?
In fact, we don't need reliability for in-memory storage, because each board is loaded, it have one instance of in-memory storage on the board server. Board server can process several such kind of instances, and if the in-memory storage library crashed, so we just reload the data from S3 again and create new instance of the in-memory storage.
And you lose all the changes.
No, not in fact, because we are saving all the changes each 15 seconds from in-memory storage to S3. If there is changes, of course. If not, we are not saving.
No, okay, thank you.
All right. Once again, that is fine. So just 2 rows front.
Okay, thank you. One more question I had. Let's say you're rolling out a new upgrade of let's say the board server, right?
Yeah.
Like you have actually 2 instances running in parallel. How do you synchronize all of them? Because you have a state in S3, and you have local copy in memory, like on the one board server and on the other. How do you synchronize that they don't conflict with each other?
So, in fact, the source of truth is the data inside of S3, because, for example, if if the server crashed and we didn't save the data to S3, that was already modified or created some content by users, we should lose it, but instead, as I already said, we send in events to Kafka, and we can fetch the latest snapshot from the S3 and to apply all the changes that was not saved to S3 from the events.
So you save data to S3 every time there is a change happening on the board?
Not every time. We are using some kind of debounce mechanism just to merge some changes.
So you have some delay between...
Yes. And this delay is near 15 seconds.
50 seconds?
Yes.
Yeah, but within these 50 seconds, is there any possibility of conflict?
No.
How do you achieve that? That's the main question, how it is achieved.
So
we can discuss it later.
Right, colleagues. So that would be an excellent topic for continuing that at the hallway, right? So we still have some more questions. Well, gentlemen over there.
I have one more question about the history of actions. Do you handle it? Do you save it, or you use S3 only as write only and save all the historic data? Or you rewrite it all the time?
We are writing the same snapshot, but S3 allows us to store versions of these snapshots, and also we have at least 2 versions between the collaboration sessions. Because, for example, if we roll out some version of the board server to the canary and it corrupts the changes inside of snapshot, we always can roll back to the previous collaboration session when the board server was in the correct version.
Okay, nice, thank you.
Thanks for talk. How do you rebalancing clients between instances of memory storage?
Basically, it's not about rebalancing to the memory storage, but to the board server, specific board server where this instance of the in-memory storage for specific board is created. We have our own written implementation of balancer. It's also written in Java, but this part of implementations is unfortunately out of my scope of my team. It's, yeah. Thank you for your question.
All right, question gone without even raising that. All right, optimization. Anyone else? Right, and well, for the 8th time today, do I really need to remind? You might win something of value if you ask questions, right? So, doesn't sound too motivating? No, really? Anyone online? No, no questions. Excellent, right.
Thank you for your talk. My question is, why didn't Miro make this decision about migrate from any database to S3 plus and memory database in 2017? Did you have any other architecture in your products or something else reasons?
Unfortunately, I wasn't worked at this time, but I guess the answer is that we were young at this time of moment, and we haven't maybe architects that could help us to make right decision. But at that point of time, we thought that Postgres is a suitable decision for us, and it served for us many years. So we didn't face a lot of problems.
Okay, thank you.
And you know, I wonder, did you mention that what in-memory cache instrument did you use, like, or you decided to use like Redis or some instrument in Amazon, like?
Maybe I get your question. So we use our own implementation inside the board server because we have no network latency at first, and all operations, we can tune our in-memory storage library for ourselves to provide best performance. And the speed of applying all operations is the biggest issue for us because we are a collaborating tool and we need to process all operations as fast as possible.
So it's the cache in backend, something like this.
Sounds like this,
In
but
this
it applies some kind of different logic under the hood, etc.
Thank you. So I see that you finally decided to raise a question. Perfect.
Okay, thank you for the talk. And about this in-memory storage, do you store data on heap or off heap?
On heap.
Okay.
Thank you for your question.
Over there.
Hello. So are you using some kind of compression to reduce the memory?
We use compression when we are saving our data to the S3.
For memory, not.
For memory, not.
Okay.
Because so in terms of speeds, we need to.
Okay.
It will affect our performance.
Okay. Thank you.
Right. Thanks. Last call. Over there.
Thank you for the talk. A question about the user changes. As I understand, you have WebSockets or gRPC nowadays, right? And users are connected to the server by this protocol. So how do you handle the simultaneous changes of the users? I guess you have to handle the order and then save the snapshot of the whole board in memory. So do you ensure that the order of these events at the time you save it to the storage is the same the user send it, and how do you do it?
Yeah, thank you for your questions. So our board server process all commands that comes from our clients sequentially. That's why the order is the same as it comes from the clients. And when we're saving the snapshot to S3, we are making saving the data that is only committed. All non-committed changes are not saved to S3.
Okay, thank you.
Excellent. Anyone else? All right. So then we move to the most joyful part of the session. Now you need to decide which question was the best in your opinion.
I guess the question about how to not to lose the data if the server crashed, and the answer was yeah.
Right.
That was.
So who raised that over there? Right. So congratulations, you win. Well, something. I don't know what that is, but that's of value. Right. So thank you once again for your presentation. And now organizational aspects. So first, the speaker will be somewhere here around the hallway, and you can continue those discussions that you had here. Another thing, you think this whole conference is over? Oh no, not yet. So we have a closing ceremony, which is happening at the Hall 1, and if I'm not mistaken, that's at 17:50. So in 10 or so minutes from now, and well then, probably it will come closer to the end. So with this, our session is now over. So if you could please find a way to the largest room over there and close the event. Thank you.